For zero order reaction, concentration of A at time t equals minus kT A0. When you compare this equation with a straight line, you get y-intercept A0 when you compare with a straight line, right? And when you get a plot concentration of A at the time t versus t, you get what? Straight line. Straight line for zero order. Now for first order you have ln concentration of A at the time t equals minus kT plus ln A0. In this one, a plot of ln concentration of A t versus t is a linear, and you get graph crosses the origin, b equals 0 when you compare with a straight line. And for second order, our equation 1 over A concentration at time t equals kT plus 1 over concentration of A0. In that case, this is a y-intercept, and you get a straight line 1 over kT versus t. Okay, 1 over A t concentration versus t, you get linear line. So that way you can find graphically. You can use graphs of concentration versus time, and then you can determine order of the reaction. For example, I'm going to give you some example, okay? And that way you can determine order of that particular reaction. So let me give you an example. I'm plotting one graph, alright? Let's say in this one, this plot is originating at 0. This is 1 over NO2 concentration, which is liter per mole, and time in second. Let's say this is a 60, 120, 180, 240, so on and so forth. Okay? Now, looking at the graph, what do you think? What is the order of this reaction? This is a second order reaction, right? So by looking at that graph, and when you go back here, you can see for the second order reaction, 1 over AT versus T gives straight line. 1 over NO2 concentration versus time, so that you can predict this is a second order, right? So you can see this is a second order in NO2. So that way you can determine order of the reaction by looking at the graph and how it originates from 0 and it gives straight line when you plot 1 over concentration of NO2 versus time. And that way you can find